Hello guys, welcome back to Juper Luper. Next week is IMOK, and I decided let's do Hamilton. Why not? And this is specifically meant to be a paper which I haven't done before, but that's not really true because I already did it and the video got corrupted and there was no sound. And so this is actually my second time doing it, which is a bit of a shame. But I can't be, I just really can't be asked to go get a new paper. We're doing questions 1 to 3. If you want to see questions 4 to 6, which I actually haven't done before, well then leave a comment down below. And with that being said, please like and subscribe. And let's go. So question 1. So when I first saw this, I thought, oh, I should read the question first. This is horrible by me. A regular polygon P has 4 more sides than another regular polygon Q, and their interior angles differ by 1 degree. How many sides does P have? Now, this is a bit iffy. It's a bit obscure. But if there was a way to link the number of sides to the interior angle, well then you'll be bing chilling. So if we draw part of a polygon, this is the exterior angle, which by the way is the same angle as this. I'm terrible at drawing. And the sum of all exterior angles add up to 360. And if a polygon had n sides, then then there'll be n exterior angles, of course, and if all the exterior angles add up to 360, and since this is a regular polygon, all of the exterior angles are the same, so one exterior angle is 360 over n, and then the interior angle is 180 minus 360 over n degrees. And maybe you might do something wrong, maybe you might have a cuckoo bad day or whatever. So to prevent that, you should check your answers. Let's use an equilateral triangle, for example, a regular polygon. It has 3 sides. 180 minus 360 over 3 is 60, and that's right. An equilateral triangle has 360-degree angles. And you can try it for a square. You get that each interior angle is 90. And so on and so forth. I really don't care how much you check. Just make sure that you check it, because checking is good for your mental health and your physical health. You should always do some checkups. Yeah, so this is the formula for an interior angle if you have n sides. You don't need to know this because it's quite easy to work it out, as we just did. And so now we just do algebra. Let's say P has n sides, because we're trying to calculate how many sides P have. And it's always good to state your variables, so when you put n, they know what you're talking about. And 180 minus 360 over n equals, or plus 1, equals 180 minus 360 over n plus 4. And this is the interior angle of Q. And you can just use like visualization to work out that if a polygon has more sides, the interior angle is bigger. But if you don't believe me, well then this bit is smaller, and so this bit is bigger because it's negative. I don't know, that I'm kind of waffling. But anyways, to this you can just get rid of the 180s, get all the fractions onto one side, and get rid of the fractions by timesing n plus 4, where you get something absurd like this. And this actually turns into 1440 equals n over n times n plus 4. You can do quadratics plus, I'm being stupid. And if you're a bit stuck at first, all you can just think about this. Think of two numbers which differ by 4, and they times to make 1440. And if you're stuck, you might want to write out the factors of 1440. Or a good trick is to work out like the range in which it's realistic. And I would say the square root of 1440 is somewhere between 30 and 40, so maybe look between maybe 30 and 45. And then when you look carefully, you may see 36 and 40, which is also a good reason why you should practice your multiplication bonds, not just your addition bonds. Remember, like, when you were like 5 and your teacher made you do like adding bonds, like number bonds. That's what they were called. But anyways, this is n minus 36, n plus 40, and n is 36 or minus 40. Maths is crazy, but you still have to be realistic. You can't have minus 40 sides, that just doesn't work. So we're left with n equals 36, i.e. P has 36 sides. B2. That's question 1. Let's go on to question 2. Hudson labels each of the 4 vertices of a triangular pyramid with a different integer chosen from 1 to 15. For each of the 4 triangular faces, he then calculates the mean of the 3 numbers at the vertices of the face. Given that the means calculated by Hudson are all integers, how many different sets of 4 numbers could he have chosen to label the vertices of the triangular pyramid? Well, this is a hard question, because you have to do some number theory, which is not very common. Or like, you have to do number theory, which is more than just like multiplication and difference of 2 squares, or like things like that. This is kind of algebraic, and it may look like question 3 also looks quite algebraic, but I actually found this question pretty hard. So you have a triangle. I'm terrible at drawing, but it's always useful to know how to draw basic shapes. Let's just have this A, B, C, D. And there are 4 faces, as it says in the question. And I believe it's this. And each of these are a multiple 3. Or, I mean, yeah, because Man, because this is an integer, and this is an integer, and this is an integer, and this is an integer. And so as a result, if we take away the brackets and like the studs, all of these are multiples of 3. And we can use modular arithmetic here, or like remainders. I.e., if you divide like this by 3, which is what mod 3 means, you're gonna get a remainder of 0. Or you have the same remainder as when you divide 0 by mod 3. That's what it actually means. And as we can see later, we can kind of abuse this. We can abuse this immediately, actually. So, if we have a plus b plus c is 0, and mod 3. Mod 3 means you're dividing by 3. Then we can add d to both sides. And then you get this. And what this means is that a plus b plus c plus d has the same remainder as d when you divide it by 3. We can do this with the second one as well. And you get this. And then similarly you'll get this. And a plus b plus c plus d has the same remainder as c. So what have we gotten here? We've gotten a plus b plus c plus d. It has the same remainder as a, b, c, and d. I don't know if you can write them. And if we remove the first part, this is actually very important. Because that means all the numbers have the same remainder when divided by 3. So it's either remainder 1, remainder 2, or remainder 3. Or 0. Remainder 0, remainder 1, or remainder 2. If it's remainder 0, then, because they're all different, remember? You remember that? You have 3, 6, 9, 12, and 15. And I don't want to go into combinatorics, but basically we choose 4 out of the 5 to get our 4 numbers. And since it really doesn't matter what order they go in, this is 5. There are 5 possibilities, because you're removing 1 from this list, and there are 5 possibilities for the number which you can remove to make A, B, C, and D in some order. And so there's 5 possibilities. And for remainder 1, we have 1, 4, 7, 10, and 13. There is 5 possibilities. 2, 5, 8, 11, and 14. There are 5 possibilities. And so if we add them together, there are 15 possibilities. There we go. And moving swiftly on to question 3. It's possible to write this big number as the sum of 3 distinct squares, using the identity a plus b, a squared plus 2ab plus b squared. Find another way to write 15129 as the sum of 3 distinct squares. So let's do part 1 first. I like to separate out. Let's do part 1 first. Okay, so 15129 equals 123 squared. And a plus b squared equals a squared plus 2ab plus b squared. And only now am I realizing that I made a mistake. I made a grave mistake in my last video. So it's good that the audio got a bit corrupted, because I get a clean slate. Anyways, enough waffling. This is a square. This is a square. And so if this was a square, well then you have the sum of three squares. So we have a mission. We have a plus b equals to 123, and we need to find two. We have to find two numbers so that 2ab is a square. And yeah, that's gonna take a long time. So let's think about this. Let's think about 81. 81 and 42, that doesn't quite work. If we have a square number and half a square number, well then we're fine. But I'm thinking and I don't see anything. Like 49, that doesn't work. 36, it doesn't work, does it not? Thirty-six, 87, 174, 25, 108, 216. That's not really a square. 9, 104, 208, 4, 119. So, okay, we might have to look somewhere else. Let's look for m squared n and nk. While k is like 2. Will this work? I don't know. But we gotta try. So 75 and 48, they multiply to get a square number. But we need 2ab to be a square number. What about 98? No. 8, okay. One of them is an even number, and the other is an odd. I gotcha. I gotcha. 45 and 78. No. 63 and 60. No. 27 and 96. No. This is frustrating. So if it's in this form, then they're both multiples of 3. Oh, it's 41 and 82. Of course it is. It's 41 and 82. This is just really thick from me. Does that work? No, because it's not distinct, is it? Oh. This is actually getting on my nerves. This is actually like getting on my nerves. Can you write 41 as a sum of 3 squares? Please say you can. Please say you can. Have we? It's 121 and 2. Okay. At least that's over. At least that's over. Wow. Plus 22 squared plus 2. I mean, God. God help me. Why did I not think of 121? That's like the most obvious. Like, that's the most obvious square ever. And also, if you're asking, I'm not looking at the answers. I'm like genuinely thinking about it. Okay. Yes, so I was right. Where you have a square and then a power of 2. God. God, that was poor. That was so poor. But we move on. Part 2. Hence or otherwise, so that can be written as the sum of 6 distinct squares. And so, how do you turn 3 distinct squares to 6 distinct squares without it being too complicated? Well, using a nice thing known as multipliers. So, for example, we can do this. And k squared plus m squared is 615 squared over 121 squared, or 122 squared, equals 225. And it's always good to know some Pythagorean triples. If you don't know Pythagorean triples, I suggest that you get a life. That's a joke, by the way. Don't cancel me. But Pythagorean triples are really good to know. 3, 4, 5, 5, 12, 13, blah blah blah, whatever. K equals to 3, M equals to 4. You have 363 squared plus 66 squared plus 6 squared plus 484 squared plus 88 squared plus 8 squared equals 615 squared. Bear in mind that this is my second time recording this, so I'm really like not in the mood. But anyways, if you want to see more 4, 5, and 6, yeah, like and subscribe. I don't know.